My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 639. In this lecture, I will continue my discussion on types of RNN. Before understanding this lecture, I request you to go through my previous lecture, that is lecture number 638. There is something called one-to-many RNN. So let me explain how one-to-many architecture looks like. There is something called one-to-many RNN. One-to-many RNN looks like this. You have your RNN unit here. Your input is just one data point. That's very important. Let me repeat, your input is just one data point. There is no sequence in input. In the input there is no sequence. There is no sequence like this xi. Just see this xi, single input. How many inputs do we have here? Xi is single input. I can say xi could be an image, which is basically a matrix. You can think of it, image can be represented as a matrix, isn't it? You can think of this xi is just like a matrix. Means your xi is not a sequence, it is a single input. But your yi's, your input is not a sequence, your output, your yi could be a sequence. That's important. Your output, your yi could be a sequence. That's why it is called one-to-many. So let me draw the architecture here. Just see the architecture. Your xi is input image, single input. If you observe this particular architecture, what you have here? You have single input, isn't it? What are the possible outputs? Just see yi1 cap, yi2 cap, yi3 cap, yi4 cap, and so on and so forth. Let's look at the structure. Your input is 1, but your output is many. So that is called one-to-many RNN. Actually, each of these boxes are same ones that we have seen before. Just try to recall. Each of this box is simple RNN. This each box is something like this particular structure which we discussed. This box is something like this. Yes, each box is like this. Each box is like this. Each box is like this. That's what we discussed, isn't it? Actually, each of these boxes are same ones that we have seen before. Each of these boxes internally are simple structures like this. Each box is simple structure like this. I can say it's simple. Each box is simple RNN. You might wonder, where is this useful? There is a problem called image captioning. The task of image captioning is that you are given an image as an input, which is just one data point, which is not sequence, and what you want to output is sentence, which explain. Your output is a sentence which explains what is there in the image. What is the image? So for example, imagine you have an image. Let me say you have an image which may contains, let me assume it contains, your input image may contains two faces. Let it be this is input image. I can say this is your input image, isn't it? This is the input image. Let's say the output would be contains two human faces. This is basically a sentence. Contains two human faces means it's a sentence. Look at this. This is actually a sentence. Contains two human faces means it's a sentence. Look at this. Contains two human faces. So your output, your yi, if you speak strictly, your yi, your output means your yi is a sequence, or basically a sentence. In this case, your input is just one data point. It's not a sequence. It's called one-to-many. Image caption is very, I can say image caption is a very standard example for one-to-many RNNs. There is third type of RNN called, there is something like there is third type of RNN is called, what is that? Many-to-many. Many-to-many. There are two types of many-to-many architectures. Let us try to understand them. There are two types of many-to-many architectures, isn't it? Many-to-many, what is the meaning? Many-to-many basically means that your input is sequence and your output is also a sequence. Your input can be here, let me say xi1, xi2, xi3, and so on and so forth. For every input correspondingly you have output y1 cap, yi1 cap, yi2 cap, yi3 cap, and so on so forth, isn't it? So this is basically many-to-many architecture, isn't it? Because you have many inputs. That's important, because you have many inputs and you have many output. Just see, you have many inputs as well as many outputs. The size of the input and the size of the output is same. This is one type of many-to-many architecture. This is a many-to-many. This is many-to-many, same length input and same length output. So you might wonder where are the applications of this? Where can I find applications of this particular architecture? If you wanted to determine parts of speech, for example, let me say I have an input. What is my input? Input is tensor is very easy. What is my input sentence? Word 1 is tensor, word 2 is word 3 is very, word 4 is easy, isn't it? What does it mean? Parts of speech means what it has to do. Your output could be, just see, your word 1 tensor is noun. Just see your output, what will it give? Just see this output. Just let me show this one. Just say this one. It says your tensor flow. This is input. Your output is noun. Tensor flow is noun. Your is verb. Very is adverb. Easy is adjective. This entire thing is input. This entire thing is input. This entire thing is output. This is many-to-many RNN, where your input length is same as your output length, isn't it? Well, if your output is your input and output, if your output is also a sequence, says that for every input corresponding to every input there is a word. This is called parts of speech detection. You are given English sentence and you are expected to find whether a word is a verb or noun, pronoun, proverb, or adjective, etc. This is one example. So detecting parts of speech for a given sentence is a very important task in natural language processing. So this type of architecture is called many-to-many RNN, where the input and output are of same length. It's often used in natural language processing tasks. So this type of architecture, it's many-to-many RNN, where the input and output are of same length. It's often used in natural language processing tasks. There is a different type of many-to-many architectures. So you can have many-to-many RNN, where the input and output are of different lengths. Let's take an example for this. Very good example for this is machine translation, isn't it? Where the task is to translate a sentence in English, let's say, to Spanish. We would like to translate a sentence in English from English to Spanish. Your English sentence may contain, let me say, your English sentence may contain 20 words, but your Spanish sentence may contain only 10 words, because probably your Spanish has better way of representing the same sentence. You could have English sentence which is of 10 words, but your Spanish sentence could be of 20 words, isn't it? The input and output could be of different sizes. That's the key point here. Now, how does the architecture looks like? So basically how your input, just see, first what is xi1, xi2, xi3 and xi4. Let these are inputs. I will just draw simple example. Suppose your input is of size length 4. You have your input here. Your output starts from where it starts. This is input. Your output starts from here. Just see here, after completion of your input, just see, it is reading all the input, isn't it? It's reading all the inputs. After reading the entire input, it is start giving output, isn't it? That's the basic idea, isn't it? Suppose your input is of size length 4. You have your input here. Your output starts where it starts. Your output starts here, isn't it? Your whole input is done here. This is your input, isn't it? This is your input, and this one is your output. This one is your output, isn't it? That's what it says. Yes, your input can your yi1, your input can xi1, xi2, xi3, xi4. Your output is yi1 cap, yi2 cap, yi3 cap, isn't it? So what you notice here, your input and your output starts after reading inputs. Remember, this is time axis, isn't it? Just see, this is time axis. So what it's doing here, first it feeds all of the inputs, then generates an output after feeding all of the inputs. So this is also called as encoder and decoder network. This input part is called encoder part. The output part is called decoder part. There is also these are also called as sequence to sequence models. So I can say there are 4 popular types of architectures we have. The first one is many to one RNN, where sentiment analysis, one to many RNN, image caption, many to many RNN of same length, parts of speech, many to many RNN are of different length. That is machine translation, isn't it? I have not written, actually, if you speak strictly, I have not written here which is one to one, because you have done many to one, you have done many to many, both type, many to many, there are 2 types. But what about one to one? One to one is basically, I can say, one to one is basically your natural NLP task, natural language processing task. You have your XI, your YI. There is no sequence. There is no sequence in input. There is no sequence in input and output, which is your standard unit, I can say, isn't it? Just for completeness, I am mentioning this one-to-one. I am mentioning one-to-one for completeness only. So in simple manner, I can say there are 4 types of RNNs: many to many, one-to-one, one-to-many. I can say it's a many to many. We have seen many to many. We have seen one to one. We have seen one to many, isn't it? There are 4 types. Means what? Actually, this is, I can say this is many to many, one to one, one to many, isn't it? This is many to one. Actually, this is just many to one, isn't it? Many to ones, many to many, one to one, one to many. This is many to one. Just check this one. These are basically 4 types of RNNs. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.